Catch up here. Last night I went ahead and put the answers to the related rate questions for you, so you can take a look at it. I mean, try not to look at it until you really have to. But let's go over a couple of basic ones here. Let me do number 11 first, which is one you should have been able to do. It's not a word problem. Like it says if x squared plus y squared plus z squared equals 9 and dx over dt equals 5, dy over dt equals 4, find dz over dt when x, y, and z are 2, 2, 1. So for you take the derivative. So since they ask us to find dz over dt, that means you're taking the derivative with respect to t. So what's the derivative of x squared? It's 2x times dx over dt. Plus, what's the derivative of y squared? It's 2y times dy over dt. What's the derivative of z squared? It's 2z times dz over dt. What's the derivative of 9 with respect to t? 0. So now let's plug in what we know. Well, dx over dt is 5. So, well, what's x? When x, y, z is 2, 2, 1, that means x is 2, y is 2, z is 1. So 2 times 2 times dx over dt, which is 5, plus 2 times y, which is 2, times dy over dt, which is 4, plus 2 times z, which is 1, dz over dt, that's what we're trying to figure out, equals 0. So to explain to you what I'm trying to do here is, let's use a different color here, orange. So this 2, 2, 1 here, that's the 2, 2, and 1. And then, of course, you got, let's go with light green highlighter here. 5 and 4 here. That's this 5 and this 4 right here. So then you just go, okay, 4 times 5, that's 20, plus 16, plus 2 times dz over dt equals 0. So that's the 36, plus 2 times dz over dt equals 0. Move the 36 over, divide by 2, dz over dt equals negative 18. So this wasn't a challenging one, that wasn't that challenging because you already got the equation. So the harder stuff is the word problem. Now, I did every single one of these problems for you. How many of you at least attempted most of these questions over the last 2 days? Okay. How about this? You go ahead and try to attempt them over the weekend, and then look at the answer key as you need to. It's step by step. I did every single one for you. Look at the answer key. You might not still understand how to do it even after looking at the answer key, which is fine. But maybe some of them you'll understand after looking at the answer key. That's fine. Then we'll talk more about it on Tuesday. Does that sound good on that? Or you want me to, is there any particular one you have to see done right now?
Professor, I have a quick question. It's for this question, it's equal to 0 because you find the derivative of 9, or the 9 becomes 0 because of this derivative?
Yeah, because we're taking the derivative of both sides with respect to t, so the derivative of 9 with respect to t is 0.
Okay, thank you.
Could you do number 13?
13, yeah.
I don't understand when it says a plane flying horizontally, like planes don't fly vertically, I guess, right? What says plane flying? I mean, because like the way that I was thinking about it was I was trying to find the situation in the word problem because we have to think about that too. So I'm trying to.
Okay, so here's what they mean by a plane flying horizontally. So like here's the station. Let me read the problem. A plane flying horizontally at an altitude of 1 mile. So it could fly diagonally. So let's say here's the station and here's the ground. Now I know the Earth is round, but we're only talking about a short distance of a few miles, so it's going to look flat. Okay. The plane is flying horizontally at an altitude of 1 mile. So what they're saying is this distance right here, this is number 13. This distance is 1 mile, right? So when the plane is flying over, let's make this orange. So the plane is flying horizontally at 500 miles per hour, meaning it's not going this way. It's going horizontally. It's exactly parallel to the ground. Does that make sense?
Yeah, it's just like using it as a number, like if it goes diagonally, does that mean that it's more positive? If it goes horizontally, does that mean it's less positive because you're going, you know what I mean? Like, because I'm trying to think of the situation when this is flying. It's specifically saying flying horizontally. So
okay, I just explained when it's flying horizontally, it's going in the direction of what I just pointed out. So this is flying horizontally. So this is the black line underneath, that's the ground, okay? So the plane is flying horizontally, meaning it's 1 mile above the ground and it's flying horizontally. It's not going like this when it's taking off. It's already in the air, and it's just you're looking at the 10-second clip that's flying horizontally. That's it. Don't think anything further than that.
okay.
Now, when you ask the question, like I'm trying to think of a situation when it would fly vertically, you're giving me anxiety.
No, it's not that. It's just because we have to, because like that problem you did before where you switched it from a positive to a negative because it was going or it was shortening the distance. That's literally that's all like I was like thinking of because that's the only part where I'm confused is because the situation of what you're talking about in the problem is
So let me finish talking about this problem here. So that this plane this arrow that I drew in red.
No, yeah, I totally understand like direction. I understand that completely. Like that doesn't concern me at all. The only concern would be like when it comes to the numbers.
Okay, well, I'm trying to do the poem. You got to be quiet.
Okay, sorry.
All right, so what was it doing? Yeah, so it's 1 mile there, so it's going 500 miles per hour. So the plane, which is going this way, it's going 500 miles per hour. So I'm going to call that X because that's what I did in the answer key. So dx over dt equals 500. Now, why is it positive 500? Because so this black dot that I have down here, that's the station. So as you see, as time goes by, this plane is going further and further, going to the right. So therefore, it's extending this line segment X further and further. So positive 500. So the question is here. Let me go. A plane flying horizontally at altitude is 1 mile. So the altitude is 1 mile. So notice I call this altitude Y because it's going to be 1 throughout this whole 10-second clip because the plane is flying horizontally. So the vertical distance to the ground does not change. It's always going to be 1 no matter where you're watching this clip. Find the rate at which the distance from the plane to the station is increasing when it's 2 miles away from the station. So they're saying, so you're watching this clip and this plane is moving across at 500 miles per hour. When this plane is exactly 2 miles away from the station, so that means that the plane is, when you catch it, it's right here. The plane is 2 miles away from the station. At that particular moment, how fast is this changing from this station? So it's going 500 miles per hour. But if it was going 500 miles per hour this way, then it's changing its distance to the station at exactly 500 miles per hour. But it's not going that way. It's flying horizontally this way. So therefore, it is getting away from the station, but not at 500 miles per hour. Does that make sense? Because it would not going exactly that way. We're going away from the station at 500 miles per hour. Do you follow me on that?
Yeah, that makes a lot more sense, definitely.
Okay, so now, so we have come up with an equation. Well, this is a right angle. So I got 1 squared plus x squared equals, now I'm not going to call that 2 squared because that's constantly changing. Remember, you can't call this 2 because that depending on where the plane is, that's going to be different. It's here, then it's here, then it's here. You can only call it constant if it's the same throughout. So we're going to call it, I know H up there. So we're going to call this H squared. Now, when I go on the side, I say, all right, when H equals 2, what is X? So we'll figure that out later. So let's take the derivative here. So you got 0 plus 2x times dx over dt equals 2h times dh over dt. Then we're going to solve over dh over dt. So then we're going to solve for dh. But before we do that, when h equals 2, what is x? Well, 1 squared plus x squared equals 2 squared. So x squared equals 3, x equals square root of 3. So you plug in x squared over 3, h equals 2, and you know what dx over dt is, that's 500. And then the rest of it, you can look at my in the canvas what I gave out, and you can see what the rest of it is. Does that make sense to you, rest of you? All right, let me look at the notes here. Wait, the Earth is not flat? So, didn't Kyrie Irving think the Earth is flat? The basketball player?
I think so. I mean, flat Earth is kind of a meme.
It's kind of what?
Kind of a meme.
Yeah. If the Earth is flat, then where does all the water in the ocean go once it goes all the way? And it's funny because the flat earther, they think that when the water keeps going, the ice wall, I'm like, that's got to be pretty strong ice if it can hold that much ocean water. All right. Are we good? Okay. So take a look at the answer, related rate answers, and we'll talk more about it later. So let's. Let me just finish this since I'm almost done with it anyway. So you plug in x, which is radical 3, dx over dt, which is 500, h is which is 2. So 1,000 radical 3 equals 4 dh over dt. Divide by 4, 1,000 radical 3 over 4 equals dh over dt. 1,000 over 4 is 250. So 250 radical 3 is the distance the plane is changing from. What is 250 times radical 3? That's approximately 433 miles per hour. So I told you it is getting away from the station, but not quite as 500, because it would have to be getting away from the station at exactly diagonally like that for it to be 500. But it's going vertically, it's going horizontally at 500. So it is getting away, but it's going away from the station at 433 miles per hour at that particular second. All right. All right, let's move along to the next section. Madison, do you approve of this question?
Yes, I approve.
3.10, differentials. Lauren, how are we doing today?
Amazing.
Amazing. Okay, when is the next trip to Mexico?
No trip to Mexico anytime that I know of,
Oh, okay.
sadly. But hopefully my dad will let me.
I'm going to be going to Mexico in 3 weeks.
Spring break?
Well, just the weekend. My friends are going, so yeah. I mean, so yeah. So don't email me when I'm in Mexico. I won't be able to answer. All right. I'll have an alcohol beverage in each hand, so I really won't be able to like check my email. All right, let's moving on here. Differentials. So if you know how to take a derivative, you should be able to find a differential. Basically, so let's say when you take the derivative of y equals x squared, dy over dx is 2x. But dy over dx is not a fraction, but if you thought of it as a fraction, and let's say hypothetically you multiply both sides by dx, then you would get dy equals 2x dx. So it actually works itself out. However, we're not multiplying both sides by dx. It's just that the notation works out perfectly like that if you thought of it like algebraically. But the differential dy equaling 2x dx, basically the differential is whatever the derivative is times dx. So let's do another one. Suppose I ask you to take the derivative of y equals, not derivative, the differential of x squared times the sine of 2x. So we got to use the product rule. So it would be first times the derivative of the second. Derivative of sine of 2x is cosine of 2x times the derivative of 2x, which is 2. That's the chain rule. Plus second times the derivative of the first, which is 2x. So normally this would be it, and then times dx. Let me simplify it a little bit. dy is equal to 2x squared times cosine 2x plus 2x times sine of 2x dx.
Is dx ever a number? Or is
Yeah,
dx?
well, I would tell you what it is when we get to those problems. Yeah.
Oh, okay. So it's a given. So it's just like dx is equal to this. Find the differential.
No, right now it's just dx. You just use times dx.
Okay.
Margaritaville. Ryan, Burrito is it's good for kids. All right, you guys listen. Y equals tangent of 3 theta plus 4. So in this case, theta is playing the role of x. So if I ask you to find dy, the differential of y, it's going to be whatever the derivative of tangent is times d theta. In this case, theta is playing the role of x. What's chanclas?
They're sandals.
Oh. Is that the new word for sandals? Chanclas?
It's Spanish for sandals.
Oh. All right, so it's secant squared of 3 theta plus 4 times, now you're going to use the chain rule, times what's the derivative inside? 3, and then this whole thing times d theta. All right, now what we're going to do is I got to explain to you the difference between the differential of y, dy, versus delta y. So suppose we got a graph here. And we'll call that x. I'm going to draw a tangent line here. Give me a second here. I got to focus. No, hold on. All right, there we go. That's good enough. So there's a tangent line. And if I go out further here, this distance, we're going to call it delta x, which is the same as equal to dx. So now delta x is a very small number, or dx. It's like usually some number like 0.1. Now, the reason why I make this distance big is imagine like we're zoomed in on a graph, like we're zoomed in. Because if I made the dx really small and you can't see the difference, if I said like, all right, look, here's dx. Well, then you're all like, wait a minute, I can't see that. So now, delta y versus dy, I'll explain what that is. This distance right here from the orange is dy. The purple from here to here looks close to black, but that's delta y. Let me put it over here. Give me 1 second. I got to make this better. So notice delta y is the exact difference between the x values, whereas dy is an approximation using the tangent line. So what dy does is it helps us get a really good approximation as long as dx is small. So notice here, when dx is small and you're very close to the original point, that red line is pretty darn close to the black graph. But as you go further and further out, the red line is going to not be that close. So dy is a good approximation of delta y when you're very close to the original x value. So why would you want to figure out dy? Well, sometimes the exact answer, delta y, would be too hard to figure out for a certain function. And remember, this is all like, sometimes before the age of calculators. So like maybe square root of 9 is easy to figure out, but square root of 9.1 is not so nice to figure out. So, but you can get a really good approximation using calculus. Or like, the same thing, like let's say if you want to do square root of 100, you can do it's 10, but square root of 101, not so nice. But there are ways you can get a really good approximation. Now, what about today with calculators and computers? Well, there's still other things that are much easier to do when you use differentials. Now, you'll learn, we'll do some approximations in a second. So just notice here, going over the formulas, dy, I already told you it's the derivative times dx. Whereas delta y, that's just the exact difference between these two guys. What's that distance, that vertical distance? What is it? It's f of x plus delta x minus the original f of x. Now, one more formula here before I confuse you too much is you can approximate f of x plus delta x is approximately equal to, well, go back here. If I were to solve for f of x here, sorry, f of x plus delta x here, if I were to solve for that, how would I solve for that? I would move the f of x over to the other side, right? So you get approximately equal to f of x, well, actually exactly equal to f of x plus delta y, but delta y could be approximated with dy, which is f prime of x dx. So this part right here, that's your dy. So this is what's used as an approximation. If I want to approximate a number that's really close to x, f of x plus delta x can be approximated by f of x plus f prime of x dx, which is dy. So these are the three formulas you're going to be basically using throughout this section. So that's why I highlighted them, put them on a piece of paper next to you, we'll refer to them. All right, so let's do some problems now. Are you guys good? You copied it down? All right, here we go. Example. Find hold on, I'm gonna make you do two things here. So A, find the differential dy, and B, evaluate dy for the given x, dx, and dx. So we got y equals 1 over x plus 1, x equals 1, dx equals negative 0.01. So here, let's go ahead and do this here. Part A, I'll do the solutions in blue. So the black was given to me. The blue is what you'd have to do. So find dy. Well, first let me rewrite it as x plus 1 to the minus 1. Take the derivative. That's negative 1 times x plus 1 to the negative 2 times the derivative inside, which is 1, times dx. So let me go ahead and rewrite it as negative 1 over x plus 1 squared, because I know I got to plug in stuff later. So that's part A. Oh, I just saw the tech. Can you go up just a line higher? Okay, can you see? Are you good now, Damaris?
Like from here, one line higher. I just couldn't catch the answer.
This one?
Yeah, I'll just take a picture of it. All right, good. Thank you.
Oh. Things better now? You're good? You got internet access? You got running
Yeah,
water?
still
Running
not
water?
at my place yet, but
Still
we'll have
not
to
what? Okay.
still not at my own place yet. Still couch hopping for a little bit.
Oh, sorry to hear that.
It's still good.
So that's the answer for part A. So that is dy. Now let's do part B. Evaluate dy for the given x and dx. All right, so dy would be equal to negative 1 over 1 plus 1 squared times dx, which is negative 0.01. That's negative 1 over 4 times negative 0.01, which is 0.0025. Desiree, how are we doing today? No last name, just are you becoming an artist? Just Desiree, that's it.
I had my name legally changed to only have a first name. Thought it would be cool.
Like Madonna.
Close.
Or
No.
you could do like Prince did, where you don't even have a name, it's just a symbol. He did that for a while.
You know what? I think that's what I'm going to do next. I need to spice it up.
Yeah. I remember when I was a kid, so in pro wrestling, I know you sometimes when they wrestle, it's not really wrestling, but you know, it's what they do. So they have their name, but if they want to switch organizations, they have to they can't use that name anymore because it's trademarked by that company. So to get around that, sometimes they'll just legally change their name to that name, and basically now you can't say I can't use this name because it's my name. So there was a wrestler called the Ultimate Warrior. He legally changed his name to Warrior. So that way, when he goes to another company, he can go by that name still. See, you don't just learn math in my class, you learn about pro wrestling history as well. All right, moving on. Next, we're going to use differentials to estimate. Use differentials to estimate 1 over 4.0. Why did I call this 4, by the way? I'm sorry, it's not number 4. The reason why I called it 4, it's in my own notes. Like, this is the 4th thing that I'm going to do for you guys. I have an order of things I'm going to do. But this is question number 24 from the book, in case you're wondering. So here's the thing when you use differentials to estimate. So 1 divided by 4 would be easy, but 1 divided by 4.002 is actually still doable if you do long division, so it's not out of the question. But you see how 1 over 4 would be much easier. So here's how you would use differentials to estimate this. You need to come up with a function f of x. So and in this case, an f of x that I would use would be 1 over x, because you're going 1 divided by some number. Now, could you use 1 over x squared? Yeah, but I'm going to go with 1 over x. It's easier. Where x is going to be 4 and dx is going to be 0.002. So go ahead and write this down, then I'll explain how I came up with it. So the x value that you pick is going to be an x value where it's very close to the number that you see in the problem, 4.002. What's a very nice number? I know this is a very vague term. What do I mean by nice? But just, what do you think I mean by nice? What's a nice number by 4.002? 4, right? Now, because I can go 1 divided by 4 very easily. I can't go with 1 divided by 4.002 that easily. Now, if I choose x equals 4, then I have to use dx being 0.002 so that x plus dx would give me the 4.002. Now, what if it was 3, if this number instead of 4.002 was 3.998, then dx would be negative 0.002. You see that? In this case, it's over 4, so you're over 4 by 0.002. Does that make sense? So now, f of x, that you're going to use this formula, f of x plus delta x can be approximated. It's approximately equal to f of x plus f prime of x dx. That's what I had here highlighted. Now, before I use this formula, I need to figure out what the derivatives are because we're going to use derivatives. So I'll come back to this formula in a second. So f of x is x to the minus 1. I just rewrote it here. I'm going to take the derivative. That's negative 1 x to the minus 2, which is negative 1 over x squared. Now I have all the info that I need to approximate. So f of x plus delta x. So that would be f of 4 plus 0.002. Isn't that f of 4.002? So notice, if I figure out what f of 4.002 is, that means plug in 4.002 here. Now I'm going to approximate 1 divided by 4.002 by figuring out what f of 4 plus 0.002 is. That's approximately equal to f of 4 plus f prime of 4 times dx. What's f of 4? 1/4. What's f prime of 4? Negative 1 over 4 squared. You just plug it into the derivative. What's dx? 0.002. Then once you get all this, you got 0.25 plus, this is negative 1 over 16 times 0.002. Anyway, you put all that in your calculator and you get 0.249875. Now, it's a very good approximation because if you just did the old school way and just said, hey, you know what? Someone who doesn't know calculus, they just give them a calculator and put this in your calculator. What do you get? 0.249875.062. You see how they're pretty darn close. The first 6 decimal places are the same. Actually 7 since it's a 0. So as long as, notice when I talk about this here, as long as your dx is small, and you see if your dx is small, the red line is very close to the black line. So you can't tell the difference right here. But when you go further out, then there's going to be a larger and larger error. So let's do another example so you can get a hang of this. I didn't have another example prepared, but we'll do one. I'll do one live for you. Let me, you guys all write this down? All right, let's do number 26. This is another even number 1 from the book. Use, again, same directions. Use differentials to estimate, or linear approximation or differentials. Square root of 100.5. So you see how a square root of 100.5 is tough to do without a calculator, but square root of 100 is easy. It's 10. So let's see here. What should my f of x be here? What function am I using? I'm going to pick a random person, and this random person is going to say the answer. If not, we will all laugh at this person. Desiree.
Honest to God, I'm lost right now.
All right. Anyone want to bail Desiree out?
Please.
Take a guess.
Is it 1 over x?
No, it's square root of x. Because you're taking the square root of something. Right? Does that make sense? Now? What is x going to be equal to? 100. Because square root of 100 is easy to do. What's dx? The leftover, 0.5. Does it make sense now, at least a little bit?
I'm seeing the pattern now. I
Oh.
think
So is your f of x always just going to be the main function that's being used in the problem?
Yes.
Okay.
So you're going to use f of x plus delta x could be approximated by f of x plus f prime of x dx. So that's the dy. Well, before I use this, I got to figure out what, hold on, erase that. I got to figure out what the derivative is first. Let's get the derivative first. What's f? So f of x can be rewritten as x to the 1/2. So the derivative was going to be 1/2 x to the negative 1/2, which can be rewritten as 1/2 times the square root of x. All right, now we're ready. So you guys do realize we're going to have to do another example after this, right? Desiree, let us down.
maybe I'll get the next one. I don't know.
So f of, so you're going to go f of 100 plus 0.5 is f of 100 plus f prime of 100 times dx, which is going to be 0.5. So f of 100, that's square root of 100. Plus f prime of 100, that's 1/2 times the square root of 100, then times 0.5. It's 10 plus 1/20 times 0.5. You can just get out your calculator. So 10.05. Now, if you do the square root of 100.5, oh, hold on, I forgot to multiply by, I did something wrong. I never want times 0.5. 1 divided by 20 times 0.5, then plus 10. So it's 10.25. Now, note, if you just did things without a calculator, if before today's class, if I said, hey, get your calculator out and tell you what the square root of 100.5 is, you would go, all right, square root of 100.5 is approximately 10.02496883. And then it keeps on going. It's an irrational number. So you see how 10.25, we got a pretty really close number, and we didn't need a calculator. I mean, I could have done this if you gave me enough time without a calculator. 1 divided by 20 is 0.05 times 0.05 is 0.25. So that's using differentials to approximate. Pretty neat, huh? Well, you don't think so, huh? All right, you're going to do one now. Running out of functions here. Let me see what I want to do. Now, this might not work out super nice, so you can use your calculator still. But give me 1 second here. 1 second. So use differentials to approximate 5.02 to the third power. Can someone, to help us get started, tell us what f of x would be in this problem? I'm going to pick a random. Go ahead.
X cubed. X to the power of 3.
Oh, yeah. I thought you said that's cute.
No. No. I wanted to redeem myself. Is it X to the power?
Yes. So f of x equals x to the third. And what will x be?
Five.
5.
And is dx positive 0.02 or negative 0.02?
Positive.
Positive, yeah. It's negative if it was 4.98 if you're going backwards. All right, now you guys finish the problem. So we would say, all right, the derivative is 3x squared. So f of x plus delta x is approximately f of x plus f prime of x times dx. So f of 5 plus 0.02, it can be approximated by f of 5 plus f prime of 5 times 0.02. So that's 5 cubed plus 3 times 5 squared times 0.02. 125 plus 75 times 0.02. How many of you got 126.5? All right, very nice. And then, of course, you can go 5.02 on your calculator to see what the exact answer is to the third power, 126.506. So the real answer is of 5.02 to the third power and this is still an approximation, but well, I don't know, I'm not sure. 126.506008. So notice this is a pretty good darn approximation. All right. Does that make sense? Now, we still got a couple more examples to do. And then of course we got another section. The other section we're not going to spend as much time on, so don't worry, don't freak out. Let's take a break. We'll start back at 4:24.